Hello and welcome to my cat channel. I'm Jazz and today I'm going to be doing an introduction to graph theory. So we'll start off with the basics of what graph theory is. So a graph in graph theory is denoted G and is a collection of vertices V and edges E. So each element of E is an unordered pair of the two vertices where V1 and V2 are vertices. If an element of the edges E is equal to V1 and V2, then the edge E joins the two vertices V1 to V2. And if the element edge is V equals V1, V1, the set of V1 and V1, then it's said to be a loop. So we'll draw some diagrams to make this a little bit clearer. So if we say have a group of vertices and we denote them V1, V2 and V3. This is a graph. If we connect these together in any way that we want, then these are edges. So we have E1, E2. We could also have a third edge here, E3. This would be a loop. So to write these out, a graph is described in sets of vertices and edges. So the vertices set V is equal to V1, V2 and V3. The edge set E is equal to, now it's not E1, it's V1, V2, but this could be denoted as E1. So our edge set is V1, V2, V2, V3, and now this loop set is V3, V3. And our overall graph, G, is equal to the set V, E. Okay? Now we'll move on. So some more definitions. We have the order is in the number of vertices, which is denoted N, and the size of a graph is the number of edges, which is denoted M. So if we look back at our example above, the number of vertices, the order of this graph, N, is equal to the number of vertices. So we have 1, 2, 3. The size of this graph, G, is the number of edges, M. The number of edges is 1, 2, 3. Now if we had an isolated vertex here, V4, then this would change the order to be 4, but it would not change the edges because we have not introduced a new edge. We'll move on now to isomorphic graphs. So an isomorphic graph is any two graphs which are the same. So for example, if we drew a square like graph, 4 edges, V1, V2, V3, V4. This is the same as this graph. 4 vertices, V1 is connected to V2, V2, let's call this V3, and this is V4, V2 is connected to V3, and V3 is connected to V4. Now, notice that we don't have to keep the same angularity of each edge and vertices. That is not included. We don't need to worry about that in graph theory. These are simply the same representation of the same graph, and each vertex and edge has the same relationship to each other vertex and edge in the same graph. So these two are equivalent to each other. And lastly, we'll go on to a simple graph, and it's just a simple definition. A simple graph is a graph which has no loops. So if we have, we'll take the example that we just did, V3, V2, V1. So this is simple. However, if we did this again, and now simply adding this loop in, which is an edge that goes to the same, starts and ends at the same vertex, is not simple. In fact, I'll just write that here. So loop is an edge which starts and ends at the same vertex. And that's all we're going to cover for now. That was just a simple introduction to graph theory.